environment, the soil fertility plus the water storage capacity of the soil. So we can have very poor soils in the E environment production and the best kind of soil in the A environmental production. And the yield we can have in this kind of soil is around 60 tons per hectare as an average of 5 years, and in the best one is around 97 tons per hectare. And Piracicaba's region is a region in São Paulo state. And when we use Vinasse in this poor soil, we can have a performance in yield like this one. Or when we use Vinasse in this one, we can have a performance in yield like a C environmental production soil. So Vinasse is a very important tool to enhance productivity in Brazil. Vinasse can also modify the soil microbiota, favoring the microorganisms that decompose organic matter. The most important organisms in Vinasse decomposition process are bacteria, and thermophilic fungi appears after 5 to 10 days, and actinomycetes are predominant in the final stages. So microorganisms release exoenzymes that depolymerize organic compounds. In the presence of water, the hydrolysis occurs. Decomposer microorganisms assimilate monomers of sugars, and the mineralization occurs, releasing mineral elements and CO2. In this paper, we study different fungi species and also specific gene families of fungi. And the treatments were nitrogen, nitrogen plus Vinasse, and nitrogen plus Vinasse and straw. And the abundance of fungi was determined after third application of these treatments. And for the 20 most abundant fungi genera study, there was a decrease in the abundance of Blastomyces, Melampsora, and Penicillium, which are fungi with pathogenic potential. So it's very interesting, this paper, because applying Vinasse, we can decrease the abundance of some pathogenic fungi in soil. And there was an increase in several other genera, including one mycorrhiza fungi that is benefic. And all genera that I pointed, I cannot see if you see, in orange, are increased with the presence of Vinasse and nitrogen. Vinasse and soil aggregation. Vinasse has an aggregating effect on soil particles due to the organic matter and the calcium content, and also the mucilage production by microorganisms. Vinasse is most commonly applied as fertigation, spraying in total area. But the way we apply Vinasse in Brazil is changing to less volume but more concentrated in potassium, applying on the cane row as a liquid fertilizer. There are many advantages, economic advantages, and also the uniformity of the application is a big advantage. Here we can see some application in the row, as we are applying Vinasse nowadays. Is a new trend for Vinasse application, so sugar mills are changing to this way to apply. And to apply this in the row, we need vinasses with potassium content between 3.5 and 8 kilos of potassium per cubic meter of vinasse. And the application is around 30 to 45 cubic meters per hectare. Another advantage of applying vinasse on the row is the possibility of mixing other inputs in the same operation. And we can mix calcium as oxides or gypsum soluble sources. And we have to pay attention not to raise pH more than 7 to avoid nitrogen losses as volatilization. And we can add also nutrients like macronutrients and micronutrients from soluble sources. And we can add also insecticides and fungicides if it's necessary. And we also can add microorganisms, biofertilizers, gels, humid acids, amino acids, and what we need using the same operation. Sugar mills have now vinasse-based fertilizer plant, where is a place where the truck arrives and phosphorus or micronutrients are added to the truck. Urea is the preferred nitrogen source, but we can use also ammonium nitrate and uran. And it's possible to mix all the nutrients that you want. Phosphoric acid has been the best source, and monoammonium phosphate and diammonium phosphate also can be used. It's interesting. Here we have many sources that we can mix with the vinasse, but it's interesting because we can have fertilization, use vinasse, customize it for each sugarcane plot, complementing all the fertilizers needed for sugarcane growth in one operation. So we reduce operations in the field, and this is very important for big areas that we have. And we can add all the nutrients we need, customizing the fields. Vinasse is also applied in plant cane as fertigation to help sprouting. It is important for planting in periods of drought. Also, we can mix vinasse with water for drip irrigation. It's not a common situation in Brazil, only in Northeast region, but we can do this, and it is recommended that the mixture with vinasse reach a maximum of 5% of the project flow rate, and that it be injected before the filtration process. Here you can see a picture with the tanks of vinasse and the tanks of water to drip irrigation. And vinasse can also be applied with pivot and irrigating bar. The bar and the pivot must be made of stainless steel, and it's possible to, the concentration is very variable, and we consider ranges of concentration. So the vinasse made by juice is less concentrated than vinasse made by molasse plus juice and molasse plus water. And so when we consider the vinasses for plant nutrition, we have to know the contents of potassium, nitrogen, calcium, magnesium, and sulfate, and all the nutrients. But let me show you the pH of this material. It's very acid, from 3.7 to 5, the range. but for all the vinasse, they are acid materials. If you look the organic fraction of the vinasse, we have high content of organic matter and at least carbon, organic carbon, and we have a little yeast and ethanol in the vinasse, and glycerol that has economic interest. And we have also organic acids. These organic acids are synthesized by plants and have functions of protection against pest attack, calcium load balancing, and maintenance of osmotic potential. So these organic acids that we find in the vinasse are from the sugarcane, are natural, but you can have also acetic and lactic acids that are generated during the process. And these acids, organic acids, they make difference when you use vinasse because they can enhance the growth of sugarcane. When you look the composition of the second generation vinasse and the first generation, we have some difference, mainly in the, not too much in the total solids and the glycerol and mannitol a little, but we have difference in the acids like acetic and butyric and lactic, and also we have phenolic compounds. So this means that we have to pay attention and apply this in the soil. When you see the pH is also acid, and the nutrient contents, nitrogen, phosphorus, potassium, calcium, are similar to the first generation vinasse. We can have also some sodium content, depend on the hydrolysis pretreatment, and can be higher than in vinasse, in second generation vinasse than in first generation vinasse. And we can have also heavy metals in vinasse from second generation. These elements that are above the limit from São Paulo State Environment Agency were arsenium, barium, chromium, cobalt, and nickel, and sometimes manganese, but it could be good if you need because manganese is a micronutrient. Second generation vinasse should still be better studied. There are few observations of the use of this vinasse in the field and the metals reactions in soils. So we need to study more this material. The concentration of these metals depends on the hydrolysis process of the cellulosic material, that I mean is the bagasse and the straw. Here we have the composition of the corn vinasse compared to first generation and second generation vinasse. The corn vinasse is also acid, and we have less nutrients in this corn vinasse. So this vinasse in general is mixed with the protein, the DDG, the distiller's dried grains, and sell as a DDG wet. So this vinasse is not used in the field, but they are mixing in the protein to raise cattle also. There are some undeniable facts about vinasse. The first, that vinasse improves yield, sugarcane yield. The second is the vinasse depends on the doses, improves soil fertility. And there is a pollution risk using Vinasse. So, Vinasse in Brazil is recommended for its potassium content. We have soils with low content in potassium, and also acid soils and sandy soils. So Vinasse can add nutrients and improve the yield, sugarcane yield. But both potassium excess and lack interfere in the quality of the raw material to produce sugar, influencing pulp and fiber, so increasing the ash content in the juice. Very high doses of potassium cause delays in maturation and drop in sucrose content. So here we can see symptoms of potassium lack, reduced growth, thin stalks, and the fan-shaped top of leaves. So Vinasse is a source of potassium mainly, and then sulfur, calcium, nitrogen, phosphorus, organic matter, and micronutrients. So it's easy to see how we have the improve in growth. In this picture, without Vinasse, in the left, in the right, with 140 cubic meters per hectare of Vinasse, it means 150 kilos of potassium per hectare. So it's easy to see improves of more than 140% in yield and more than around 190% in yield using Vinasse in Brazilian soils. Vinasse has can change a little the soil pH. Although we are applying an acid material, the decomposition in soil increase the pH. So in this chart, we are seeing doses of Vinasse, increasing doses of Vinasse, and increasing pH. So I don't have the pointer here, but in short term, soil pH was increased, but in the medium and long term, the pH returns to the initial value or increase slightly. The reasons for pH increase is aluminum complexation, reduction reactions that consume hydrogen ions, and increased microbial activity. Thank you. And the oxidation of organic matter. In this experiment, the soil samples were taken 3 months after the 3rd year of Vinasse application. This. Okay, thank you. Okay. Thank you. Here we have the organic carbon, nitrogen, and carbon and nitrogen stocks in different systems in an experiment in northeast region of Brazil. So carbon and nitrogen stocks were measured at 30 centimeters deep in soil samples. And the soil was a sandy texture, a typical dystrophic argisol. So Vinasse was applied at 60 cubic meters per hectare, diluted to a irrigation deep depth 60 millimeters, which applied with sprinkler. And then they use also 30 kilos per hectare of urea in top dressing. The area without Vinasse had only the mineral fertilization, NPK 60, 120, and 8 kilos per hectare. And the areas were with 10 years of sugarcane cultivation applying Vinasse. So stocks of carbon and nitrogen was higher in the soil plus Vinasse compared with the soil without Vinasse. And the stocks with the soil plus Vinasse. But compared to the native forest, they still need more years to recover the soil fertility completely. So conditions are better when you use Vinasse, and we have stocks higher, then we don't use Vinasse. We only use mineral fertilizers, but compared to native forest, there is some lack. Here we are showing the organic carbon, the macroporosity, the microporosity, and the penetration resistance in 10 years after Vinasse application. The application was 70 cubic meters per hectare per year, and around let me say that it's a pleasure to be here, actually an honor to be in India, the country that I really love. Today my presentation deals about utilization of Vinasse as soil amendment, consequences and perspectives. Some numbers from Brazil. Sugarcane in Brazil has huge numbers. The production the last season was 638.4 million tons of sugarcane. Sugar, 42.7 million tons. For intern consume, 10.5 million tons. And for export, 32.2 million tons. And ethanol, we produced 30.9 billion liters. For intern consume, 28.7, and for export, 2.2 billion liters. And also, sugar mills produced bioelectricity, 1,000 megawatts. That it means 3% of Brazil's energy matrix. Our yield was 75 tons per hectare as an average of 5 years. One cane plant plus 4 ratoons, and we produced 139.6 kilos of sucrose per tons of sugar cane. So huge numbers. And we have 2 main regions for sugarcane production in Brazil, the Northeast region and the Center-South region. In the Center-South is the main region. São Paulo state is the main state producing sugarcane, but both regions are very far from the Amazonian forest. Brazil has now 398 sugar mills in operation, 261 in the Central South region, and most plants produce sugar, ethanol, and bioelectricity, and therefore also produce wastes, including Vinasse. During the sugar and ethanol processing, 9 different residues are generated, and all of them are either reused in the process or have economic value and are sold in a circular economy. So we can see for 1 ton of sugar cane, we produce around 110 kilos of sugar and 13 or 80 liters of ethanol, depending if it's a distillery or a sugar mill and a distillery joint. So we have the harvest residue, 170 kilos per ton of sugar cane, bagasse, 220 kilos per ton, and sugar mills use bagasse to produce energy. We have filter cake, 35 kilos per ton, use it as a fertilizer. Molasses, 26 kilos per ton of sugar cane, and it's used to produce ethanol. Then we have Vinasse, 150 or 1,040 liters per ton of sugar cane. We have wastewater, and we have also ashes, 10 kilos per ton, and yeast recovery, 3.4 or 20.8 grams per tons is an average. And also CO2 yeast, the sugar mill sells to raise cattle, and CO2 they sell to produce beverage in the beverage industries. So what nobody says is that huge numbers means also huge problems or huge challenges. So we have per year around 142 million tons of bagasse, 22.8 million tons of filter cake, 6.5 million tons of ashes, 400 billion liters of vinasse, and 110 million tons of harvest residue. All these huge numbers means challenge to manage every year in the sugar mills. So vinasse is the residue from ethanol production. After the fermentation of the must, we have the wine. In the distillation of the wine, the alcohol is separated from the aqueous residue, which we call vinasse. Vinasse is an organic material rich in nutrients and energy. So the fermentation to produce ethanol can be done use cane juice in the distilleries, or molasses plus water, or molasses plus more juice, cane juice. So the vinasse that will be generated are different. So we have vinasse from cane juice, from molasses plus water, and molasses plus juice. And they differ in the concentration of soluble solids and nutrients. Vinasse is generated in different rates. In the distilleries, use sugarcane juice for fermentation. The generation is 14 to 17 liters of vinasse per liter of ethanol. In the distilleries with pre-concentration of the juice, the generation is 9 to 13 liters per liter of ethanol. And in the distilleries joined with sugar mill that use molasses plus water or molasses plus juice for fermentation, the generation is 10 to 14 liters per liter of ethanol. So the average is 13 liters of ethanol per liter 13 liters of vinasse per liter of ethanol. It means 400 billion liters of vinasse every season. And we have different types of vinasse too. The vinasse from the second generation ethanol, and the vinasse from the corn fermentation, and other materials like sorghum or cassava. So when we talk about vinasse, we need to know which kind of vinasse we are talking about. And also, we can concentrate this vinasse. In the concentration process, water is evaporated and recycled, and nutrients and organic matter are maintained. Concentrated vinasse is considered an organic fertilizer. It's not a residue anymore, and registered in the Agriculture Ministry, and is therefore a byproduct of ethanol. The composition of the vinasse is 93 to 97% water and 7 to 3% solids. And in the solids, 75% is organic matter, 25% in minerals. Organic matter enhances soil fertility and has an energy potential. And the mineral, 25% minerals, depending on the dose of the vinasse, we have the improve in soil fertility and sugarcane nutrition. So if you take a look in the concentration, in the characteristics of the different kind of vinasse, we have We know that to apply Vinasse without mixing it with water, but it's also important to filter it. Let me say something about Vinasse and environmental impacts. The first one is soil salinization. Depends on the doses. In general, there is no risk in Brazil because we use Vinasse in a dose to add potassium to sugarcane according to recommendations, so we cannot have soil salinization, but it is a risk. And also another risk is anion leaching, and also the doses that you use potassium in Brazil is very safe. But the greater risks occurs in sandy soils with shallow water table. Greenhouse gases emissions, practices that minimize impacts on the soil and air are recommended. And we have also some accidents during application or in reservoirs. And both of these need for environmental monitoring. So we have to prevent this.
Last 2 minutes.
Oh, I'm finishing. So soil salinization, it occurs only in accidents like this in the channel that broke. And here I would like to show how the risk of pollution by ions leaching. We are showing here the soil solution and the cation exchange capacity. So when we add Vinasse, we are adding potassiums and also sulfur, but when a potassium meets a nitrate, we have one positive charge and one negative charge in the soil solution, and this, the charge is 0. And in this moment, we can have the leaching of the potassium in the nitrate, but it's very ephemeral. So potassium can separate from nitrate, but in the moment they are joined, we can have the leaching risk. And if the soil is sandy and not too deep, the risk is higher. And we also have some risk of flooding, especially when applying by fertigation, like sprinkles. And we have also some greenhouse gases emission, especially because we have Vinasse plus straw plus filter cake, so several residues. And here we show an experiment where we apply Vinasse 30 days before the nitrogen fertilization and 30 days after. And here the fluxes of N2O. And when we apply 30 days before the fertilization of nitrogen or 30 days after, the emissions were very low. But when we apply together nitrogen plus concentrate Vinasse, we had the high N2O emissions. But losses represent at maximum 1.8 of the nitrogen applied. So they are not significant losses from an economic point of view. But for an environmental point of view, we have to take care because we have large areas of sugarcane and Vinasse application. We can have some accidents and need to be avoided. This is a reservoir that broke, so Vinasse ran to the river and polluted the river, so we have to monitor this. Also, we have some options to Vinasse treatment, the physical chemical treatment, the biodigestion, and the burning boilers. The physical chemical treatment process was developed in the 70s and is not an economical viable option for Brazil today. But the biodigestion of Vinasse, this is a good idea, and sugar mills are improving this process. And we can have a huge amount of biomethane being producing every season, and this volume can replace all diesel used by sugar energy sector. Okay, concluding. So it's interesting, just to say this, the biogas, the biomethane can also be used to produce hydrogen for batteries and for green ammonia, that is a green fertilizer. So concluding, Vinasse is an organic material rich in nutrients and energy, increases agricultural productivity, sugarcane longevity, and improves soil fertility. Risks of environmental pollution, salinization, ion leaching, and greenhouse gas emissions are dependent on the dosage and management used. Concentrated or enriched vinasse applied to sugarcane rows allows for flexible fertilization with economic and environmental advantages. The processes that aim to use vinasse for energy production are viable and allow nutrients recovery for sugarcane nutrition. Monitor and minimize the risks of environmental impacts is necessary. So, thank you so much.